Thanks. Bye.
Cool. Claudio, you want to
Yeah,
go
sure.
next?
Yes, sure. My name is Claudio, and I work in machine learning engineering in the travel industry.
My name is Caroline. I'm currently a student taking a boot camp at Europe United, and in my personal and some professional experience in front-end web development.
Thank you.
Awesome.
It's awesome to meet you all.
Yeah, thank you. Maybe you can go to the next slide. So we won't go into the details. I think this is the standard format of laying out the problem and solution and architecture demo, and then some challenges in learning, and then future enhancements that we've planned for the product. If you go to the next slide. So the problem that we are trying to solve is on personalized tutoring, and we did some market research to figure out, how many students complain that the current modality doesn't match their learning pace, and it's 67%. We also discovered that although there are online solutions, but 50% of the students disengage within 10 minutes of learning something new. So it's very difficult to continue to engage them. Thirdly, there is high cost. There are solutions available which are more personalized, like you could go to Mathnasium or you could get a teacher on Wingy, but those are expensive and typically ranging from around $40 to $100 per average tutor cost. And finally, one of the biggest problems that motivated us to work in this direction is I would like you guys to make a guess on how many students drop off because of math in high school. Any guesses?
No idea. I didn't even know they drop off.
Well, the drop-off rate is pretty high in high school in the United States, and it's actually 80% of the students who drop off because of stringent math requirement or science
Wow.
requirement. More specifically, this number talks about Algebra 1, which is kind of the primary culprit for the drop-off rate.
I see.
So those are some of the problem statistics and the size that we saw, as well as the magnitude. And if you go to the next slide, we did some more analysis on what particular subjects in mathematics. And there is 80% drop rate, and it is not getting better, is what this chart is trying to show. That the trend is that Algebra 1 in 2017, 2018, as compared to 22, 23, it's 6% higher rate of students who are dropping off because of that, as well as Algebra 2 and Algebra 2H and calculus. There are certain subjects like geometry and calculus AB where you wouldn't see, pre-calculus where you wouldn't see that the trend, but overall algebra and calculus could be attributed to the primary drop-off rate, and it is not getting better. So if you go to the next slide. For the students, the primary problem after doing some root cause analysis is lack of information and awareness on how they can get help, as well as the motivation and convenience in getting that help. So when you are stuck in solving a problem, you don't really know how, who to seek out for help. You're not aware of the resources that are readily available to you, and you don't know what is the next best action for you to take. At the same time, because of this, they don't make it a priority, and they forget to schedule or follow up on whatever they were stuck on because it's out of the way, and then out of their mind as well. So to solve these problems, we are building out AI tutoring solution with three primary benefits. First is scale, which we talked about, that if you start personalizing and go to a particular physical institute where you can get some personalization as well, like Mathnasium, etc., but it is expensive. So we are tackling to solve the problem of lowering the cost of getting that personalized attention. And at the same time, we want to build out a personalized solution that is catered to your modality of learning. There is ample research done in the education sector on on learning styles and how it impacts your engagement. So we want to make sure that we are teaching at the right level, which is we figure out where you stand with respect to Algebra 1, how much do you know, and then adapt the curriculum, as well as have the right modality, whether it's a video, whether it's a textbook, or a picture that will help you, or just pure text. So we are multimodal in that nature. Um, and all of it to just get better learning outcome and more engaged students. Go to the next slide. Um, we also looked at the demographic. Right now, we are targeting the US market, primarily the middle school and high school students, and only in US. It is the biggest market by far in terms of um, the size of the market per se. That being said, we do want to expand it into additional areas like Asia and Europe. Asia is definitely one of the most, emerging bigger market, which we believe that, based on some statistics, that 60% of the high school students are going to be in the Asian market, just because of the sheer size of the population of the market. But nevertheless, the financial size of the market is still US, that is the biggest, and almost 40% of it. So that's where we are focusing on, and we would expand in additional territories as well. If you go to the next slide, we also did some analysis on, how do we want to position and have unique value proposition which is differentiated. So we looked at human-centered tutoring, and there are competitors over there. Um, and then we also looked at how AI is used in edtech for now, and then have intelligent infrastructure for learning delivery. And we believe that if we solve all of these problems and be in that sweet spot, that's a unique value proposition which doesn't exist. There are, of course, um, solutions like Duolingo, which is by far the best solution that we have seen, but it's mostly focused on language, and we want to extend it to sort of additional things as well, if you will. At the same time, have more human in the loop approach also, and leverage more of the agentic infrastructure that's emerging as the way to solve this problem. If you go to the next slide. Um, so I wouldn't spend a lot of time here, but essentially what this slide is saying that as to what would be the journey. So the first thing is going to be we would recognize and onboard the student, which is to say that we would do a demographic, psychographic profiling of the student to figure out what is the right modality and what are the motivators for that student, as well as we would do some adaptive learning by sending in seed questions and gauging the response to figure out what is the right level for you to learn. And then the second step would be to personalize and curate the content that would be delivered in the right modality. And the most critical piece is actually the real-time feedback. In a sense, yes, we can build the content, it is personalized, we know how to deliver it. But if you are getting stuck in a problem, we want to make sure that we are delivering you help in the workflow itself, in the context of that digital experience of you interacting with our system. And that's kind of the real-time feedback angle that we are pushing for. And then finally, we would recommend not just to the students, but to the educator as well with analytics as to, what is the next best thing for you to learn, etc. So that's kind of the whole virtuous cycle that we want to build out. If you go to the next slide. Um, this talks about the overall architecture and the user flow. Of course, there are a lot of user flow, but we are focusing for the demo only on the student's workflow and the real-time feedback aspect as to how can we make it super easy and convenient to get feedback with these intelligent agents. But overall technical architecture would comprise of a student module, knowledge module, and a tutor module, along with a whole set of segmentation, curation, and integration services with the rest of the system. Um, let's go to the next slide. And this is where we would demo that on the web interface. So as we said, we want to make sure that we deliver content in a very accessible way. So we would have a mobile interface as well as a web interface for students to get access to help. And what Claudio is going to demo is how you can actually get real-time feedback on on a math problem and you're getting stuck. Go ahead, Claudio.
Sure. So the student in this case can select an image of his work. So basically, he can take the image using the iPhone, for example, and then upload to the system. And then the system will, using AI and different agents that basically will provide the analysis of all the steps that the student follow, his resolution, and provide custom personalized feedback to the student, pointing to specific errors and mistake, and recommending any additional content in the internet dynamically tailored to his fill all his gaps. Also, the system is able to basically validate any program resolution, and in the case that the student was successful completing the problem, will congratulate the student, and also potentially giving the student additional information, additional content in the internet.
So this is to further build on our website overview from the tutor or teacher perspective of the student that's using our platform. And in this example, we have a student named Olivia Bennett, who's a sophomore in high school taking calculus and algebra. And over here, we have her metrics, how much time she spent with the platform, difficulty and accuracy, and other metrics that a teacher or tutor would be interested in looking at. We also have her progress and her success rate over time, because that's what our tool is measuring. And also importantly, what learning method that the AI gives her, which one produces the best results.
Okay, now that we have seen what happens in the backend, let's see what the user sees and how it interacts with the user interface with the app. So the dashboard gives the student a quick view of their progress, and they show the problem submitted, success rate, and also a score of 4 out of 5. And there is also a personalized button that encourages them to pick up right where they left off. So this keeps the experience continuous. And if you scroll down, the student sees a visual breakdown of problems by category, and they can toggle between time periods to explore their trends over time. On the difficulty chart, it gives insights into which problems challenge them the most. And further down here, we can see an all-time overview, and this helps the students reflect on long-term progress. The Achievements tab highlights badges and milestones, reinforcing progress through gamification. So now to solve a problem, tap the main button, you snap a picture, and here the AI kicks in. The mistake detection agent flags the error, the explanation agent breaks it down, and the hints agent guides them forward. And the student has the opportunity to correct, and once corrected and re-uploaded the problem, let's see. So the student will now get a congratulatory screen and will also earn a badge. So again, this is where gamification comes into place. But what if the student makes another mistake? So here the system is ready. As you can see, the hints agent not only identifies the issue, but also it recommends learning modules and resources to help close the knowledge gap of the students. So this is where our AI becomes more than just a tool. It becomes a learning companion. And this is the heart, this is what stands at the heart of this app. It's supported, it needs to be smart and always evolving with the student. Now of course, we had some challenges and learnings, and most of the challenges that we needed to make sure this the whole user interface, the interaction is accessible for everyone, and also selection of the technical stack. So we choose Crew AI as the agentic framework. And in terms of key learnings, the human-centric AI wins because we are designing this for people. And and we had an amazing collaboration, and we realized that that was essential to make this solution. Moving forward, in terms of the future enhancements, so we have follow the double diamond design thinking framework. We've went to the discovery phase where we've done the project exploration, market analysis. We have defined the problems, the teams, the opportunity areas, how my we questions. We have got to the stage to develop. So we have done an ideation, UX, UI, technical infrastructure, and decided on algorithms. Now, moving forward, we would need to do more usability testing to validate and get some real feedback from real users, reiterate, establish the tool and resources. We would need to expand our resources and the team. And as AJ mentioned at the beginning, we will expand beyond the US market. Okay, so thank you so much. I hope you enjoyed it.
That was a wonderful presentation. Starting with Ajay, that was an amazing pitch. I almost forgot this is hackathon, and I felt like someone from a startup company is selling the product to me. So thank you so much. And Alina, amazing UX. I am a front-end person. I've seen a lot of great UXs, and this is one of them in such a short amount of time, especially when you have both the desktop client and the mobile version. You've thought about the responsiveness, so that's really nice because mostly it's just very easy to check your status on the go. So mobile version is really beautiful. I did want to see the code a little bit though. I saw the architecture, it's multi-agentic. We want to see what kind of model
Sure.
did crew AI you used. Just a quick sneak peek of the code would be great.
I can share
And
it.
that's it.
I
Go
need
ahead.
to.
Was
Yeah,
there any
meantime, this is
question?
really good presentations. Thank you so much, team. This is well planned and properly aligned. It's a nice presentation. That's good. Thank you so much. So I hope you guys did some kind of analysis, right? So, okay, where the market is, I like Ajay's explanation. So where we can go and sell this product. That's great. Thank you so much for sharing this.
Thank you.
Thank you. Yeah, I think Claudio was gonna share. I think maybe
I think
he
Claudio
clicked the
dropped
wrong
off.
button.
The share is next to the leaf, so
Yeah, I think so. That's the problem. Okay, he's back now.
Sorry, I had to.
And
Sorry, I
in
had.
all the demos, even though you spoke about multimodal, I saw the images being one of the inputs, but can I just type an algebraic equation and just give it? Because the UX had only an option to upload an image, not a manual entry.
Yes.
So is that something that you guys were planning?
I mean, the idea was basically to make super easy to the student to submit work, right? So that's the idea. So basically, usually the student work in a paper, right? They work. I mean, the UI for developing math and it's a piece of paper, right, where the student write the solution, right? So we want to make it super easy for a student to with with his phone and basically take a picture of the problem and then submit instead of having to type the problem. I mean, think about that. It will take five, let's say 30 seconds to get feedback versus 2 minutes typing and maybe even making mistakes with typing, right?
That's
Yeah,
So
and
true.
just to
that,
add to that, I think, for math, especially if you're dealing with equations and symbols, you need to have more like typically if you're writing research papers and all, you would use LaTeX and some sort
yes,
of an additional thing apart from usual editing. So the barrier to entry is much higher. That being
Correct.
said, as from the solutioning perspective, it's going to be even easier if for us in the back end to parse that input because it's not really handwritten. It is already parsed and there are symbols that we can read up. So from the technical
Great.
perspective, it's going to be easier to get things written in an editor, but the barrier to entry is going to be higher versus, you just scribble something quickly on a paper and upload it and you get some feedback. That's going to be like a much faster way to engage.
I
So we'll
really,
support both.
okay.
That's the point. But
Yeah.
we wanted to focus on reducing the time to get feedback.
I really love the usability perspective. Thank you. That's what I wanted to understand. What was the thought process to going with an image versus a text? All right. Let's quickly see the code and then we can move on.
So yeah, so basically I can go over the code. The core of this basically we're using a multi-agent solution. So basically Crew AI. So how we design the solution? We design the solution basically configuring 3 agents. So one agent is the problem expert, who basically is expert in giving feedback to the student. The other agent is basically content expert, who basically is expert in recommending a specific goes to the internet and get actually real time content, right? Searches in the internet. It's an agent that searches in the internet and curate specific content to the student. And the third agent is basically like a tutor that basically consolidates all the information about the feedback, the errors that the expert identify, the hints, and also the content, and provides the final answer, right? So those are the agents. And also the agent, basically each agent performs a number of tasks. So one of the challenges that we had is basically how we can actually get the problem resolution without the LLM completing the problem, because the LLM tends to complete things, right? So one of the things we had to do is basically design a task that basically what is the specific goal of the task is basically to read the problem and extract the text, right? Then the next task is the problem reviewer, right? We basically review the text, the resolution submitted by the student, and basically evaluate the resolution, and then basically identifies all the errors, and then the content reviewer will having identified the mistakes and knowledge gaps that the user did, searching the internet for content, right? And finally, the editor, right? So this is basically in general how we split the different aspects of the solution in terms of agents and tasks. Do you have any questions?
So when you use the front end to upload this image, so how do you kick in the agent there? So how is the wiring happening? Like right from the time you click, okay, this is the image upload. A little bit of walkthrough
Yeah,
of that.
absolutely. So basically, it's submitting here's the code. So basically, submitting basically the image to it's a Flask server. Basically, the user upload the image to the website, right? And then this is the line that basically starts the crew, right? And the crew basically is, as I show, basically it's a process. It's a sequential process. So basically, the students who upload the file to the server, right, will basically persist the file to a directory, upload directory in this case, and then it basically the crew of agents start reading this file and start the process. So this is
Okay,
the
can we
line that
go to
actually.
Can you get into the
the math agent crew? Can you double click on that and then see what's there?
So this is the magic agent crew. Basically, it reads basically the configuration of agents and tasks, right? That I showed before, right? And then this basically uses 2 tools, right? In this case, we use OpenAI GPT-4o because basically it's an LLM that supports multimodal, right? And also uses two tools, the vision tool and this tool is a search, right? Vision tool is basically a tool that is for basically prompting the LLM with an image, right? So this is the first. So basically, that's I don't know if you have more questions. So basically, this for each of the agents and tasks, there is a method in this class.
Okay, I think this is good. We have a hard stop here because we need to jump on to the other one. Raja, did you have any question? I've seen
No,
what
I
I
think
want to say.
you covered up that. So maybe we'll take a look at that code later.
Awesome.
Awesome.
Thank you so
Thank
much.
you so much. Thanks a lot, team. It's a
I
Thank
think
great
you
in
so
work.
one
much.
week
Thank you as
we
well.
could accomplish.
Thank you.
Yeah. Bye.
Nice
Yeah,
to meet
it's the
you.
best thing.
Bye.
Bye.
Thanks, everyone. Thank you so much. Bye.
Thank you.
Thank you.